A first order linear equation is of the form dy by dx plus p of x times y is equal to q of x. Now this can't be solved by any of the previous two methods that we've had. And first we'll illustrate the theory, but then we'll find the general solution of dy by dx, which is 2xy is equal to x. Let's just have a look at the general form. So the first order linear equation, which is written in the form dy by dx plus px of y is equal to q of x, can be solved by this new thing called what's known as an integrating factor. Now the integrating factor is going to be e to the integral of px dx. Now, but in order to find why this works, let's look at e to the integral of px dx times y, and then differentiate that with respect to x using the product rule. We will have d dx of integral of px dx y is equal to u, which is going to be, using the product rule here, integral of e to the integral of px dx times the derivative of y, which is dy by dx, plus y times the derivative of this. Now if you derive something, find the derivative of e to something, you differentiate this bit and put it in front, so you're going to get p of x e times the integral of px dx. Pause the video and just have a think how you would actually integrate something like e to the 2x or e to the 3x or e to the x squared. Right, we'll call that equation 1 and call this equation 2. We'll multiply equation 1 by the integrating factor e to the px dx. So you're going to get e to the px dx times dy by dx on this side, plus p to the x e to the integral of p to the x dx times y is equal to e to the integral of px dx times qx. Now you might have noticed here what you've got is actually that. So just writing that out again. So all this here will now become d dx of the integral of p to the x times y is equal to the e to the integral of p to the x dx times q of x. Now if you integrate both sides, this side here will just become, if you differentiate it and integrate it, you get back to what you started with, so it's e to the integral of px dx times y, and here we have the integral of e to the integral of px dx times qx dx. Now this thing here, e to the px dx, is called the integrating factor. Now let's see how this works using that example that we have. So the example is dy by dx plus 2xy is equal to x. So dy by dx plus p of x times y is equal to q of x. So the integrating factor will be e to the integral of px. P of x is 2x. So we're going to have the integrating factor will be e to the integral of 2x dx. So p of x is 2x, and if you integrate 2x you get x squared. So the integrating factor is e to the x squared. If you multiply e to the x by everything here by e to the x squared, we get e to the x squared dy by dx plus 2x e to the x squared times y is equal to e to the x squared times x. This bit here will become the differential of the product e to the x squared times y. So basically this is the bit here, y times the integrating factor, and on this side we just got e to the x squared. So we need to find y as the subject, so you now integrate both sides with respect to x. So we get, if you differentiate and integrate, you get e to the x squared times y, and here we have the integral of x e to the x squared dx. Now this side just becomes the same. If you differentiate e to the x squared, remember you get 2x e to the x squared. So this will become, if you integrate it, e to the x squared times a half. If you're not sure, differentiate that back and see you get back to that, plus c. If we now divide by e to the x squared, you're going to get that y is equal to a half. E to the x squared will cancel out, plus c over e to the x. So y is equal to a half plus c e to the minus x squared will be called the general solution for this particular problem. So here I've shown you how to use the integrating factor to solve first order linear equations.